Okay, we're gonna solve the exercise for lecture number 3 at the end of the lessons. So we'll start by the first one. It says in a long-range microwave communication system operating at 9 gigahertz. So it's operating at 9 gigahertz. The transmitting and receiving antennas are identical, and they are separated by 10,000 meters. So we have an antenna, which is a transmitter, and we have a receiver antenna, and they are identical. So and they are separated by a distance of 10,000 meters. Okay. To meet the signal to noise ratio of the receiver, the receiver power must be at least 10 microwatt. So we say that PR must be 10 microwatts. And assuming that two antennas are aligned for maximum reception to each other, including being polarized match, what should be the gain in dB? So they're identical antennas, they're polarized match, so we say that PLF, polarization loss factor, is equal to 1, which is the maximum value for like being polarized match. So in that case, we are looking for the gain of the antenna, and we had a power transmitted is equal to 10 watts. So we know that the antennas are identical, so the gain of antenna 1 is equal to the gain of antenna 2. And okay, so now we're gonna we know that frequency is equal to 9 gigahertz, so the wavelength of the antenna wavelength is equal to 10 times 10 to the 8 divided by 9 times 10 to the 9, and that will give us 130. So we use equation 2-19 119 from the Balani's book, where it says that PR PT is equal to wavelength 4 pi r, this r is the distance between the antennas, square, and the gain of the transmitter antenna and the gain of the receiver antenna. So if we put all the values into this equation, we already know we had the power received, which is 10 times 10 to the minus 6 watts divided by the power transmitted, which is 10 watts, equal 130 4 pi and the distance, which is 10,000 meters square, and what we want to find is the gain of each antenna. Since they are identical, the gain of the transmitter and the receiver are the same, so this is gain square. So this turns out to be, for gain, is equal to pi, which turns out to be in dBs around 35.76 dBs.